Okay then, it's time for another challenge. So this is the digit sum challenge. In this challenge, your task is to write a method with the name sum digits that has a single parameter named number of type int, and it should return an int. The method should only take a number that is a positive number. If a negative number is passed, it should return -1, meaning an invalid value was passed. The method should pass out each digit from the number and sum the digits up. So if 125 is the value passed to the method, the code should sum each digit, in this case 1 plus 2 plus 5, and return 8 as a value. And another example, if the value is 1000, the code should sum each digit, 1 plus 0 plus 0 plus 0, and return 1 as a value. If the number is a single digit number, simply return the number itself as the result. So how do you think you'd go about doing this? Well, I think you'd agree you could use a loop, but how would you pass out the digits? And using only concepts we've learned to date in the course. A hint here is to use n modulo 10 to extract the least significant digit or the rightmost digit, and use n equals n divided by 10 to drop the last digit as you are looping. Try that out now. Pause the video, and once you're finished, come back and check out my solution. Alright, so how did you get on? Hopefully, you managed to figure it out. So let me talk about how I'm going to go about doing this. I'll use the number 1234. When I add the 4 digits in that number together, I'll get 1 plus 2 plus 3 plus 4, which is equal to 10. In reality, I'm going to do the math in reverse, starting with the last or least significant digit 4, then add that to the next to last digit 3, and then to 2, and then finally add the one at the left. Let's look at what this process is going to look like on paper, and then I'll go about coding it after. At the start of the process, number equals 1234, and our variable sum equals 0. If we use the remainder operator, getting the remainder of the number divided by 10, this will give us the rightmost digit in the number. 1234 modulo 10 equals 4, and 4 is the last digit, or rightmost digit. Since we'll be working through the digits from right to left, we'll add this to sum. Sum equals 4. Next, we want to drop that rightmost digit, 4, and just have the remaining 3 digits to process. We can do this by dividing by 10. 1234 divided by 10 equals 123. Dividing an integer by 10 has the effect of truncating the number, cutting the most rightmost digit off, and I am left with 123. If I make a number a double, dividing by 10 would have given me 123.4, and that isn't what I want. So having the parameter number be an integer lets me truncate the number when I divide by 10. In each loop iteration, I'll be effectively dropping that last digit, which I can call the least significant or rightmost digit. So in the second iteration of the loop, number equals 123 and sum equals 4. And again we use the remainder operator, getting the remainder of the number divided by 10, which gives us the rightmost digit, 123 modulo 10 equals 3. And we'll add 3 to sum, which was 4, sum equals 7. And now we divide 123 by 10, 123 divided by 10 equals 12. So in the third iteration of the loop, number equals 12 and sum equals 7. And we again take number mod 10, 12 modulo 10 equals 2, and 2 gets added to sum equals 9. And we again divide now by 10, 12 divided by 10 equals 1. Now our number is a single digit, number less than 10, and here we'll break out of the loop. So in this final step after we've broken out of the loop, number equals 1 and sum equals 9. Now I can just add this last single digit to sum, and I'll have a final sum of 10. Okay, so that's how I plan to process the number passed. I'll hop back into IntelliJ and go through this step by step. You can see here that I've already got my project created, which I am calling Digit Sum Challenge, and I've got the main class and the main method as usual. The first thing I'll do is add some test code in the main method. I'll print out some text with my test number and then use the method in the expression passing it that same number. I'll set up 4 tests to start, and the test values I'll use are 1234 from the slides, minus 125, 4, and 32,123. You can set up any tests you want, but you should try at least one negative number and one single digit number. Remember, the single digit number should just return its own value. I'm going to type out the first print statement, and then I'll copy and paste the rest. This println will print out the 1234 then the return value from calling the SUMDIGITS method with this value as the argument. Okay, so my test methods are set up, and I'm getting IntelliJ errors because I haven't coded the method SUMDIGITS yet, so it's time to do that. I'll add the new method under the main method at line 11 and use the usual public static keywords. I'll start by creating a local variable for sum, initializing it to 0, and then I'll return that variable from the method. So that's the definition for my method, and confirming that I'm returning sum, which right now will always be 0. The requirements of the challenge said that we shouldn't accept negative numbers, and if a negative number is passed to the method, we should return -1, so I'll code that next. I'll add that before everything else, so if number is less than 0, I'll return -1 right away. Is number less than 0? Yes. Then return -1. Time to code the loop. I've talked about what happens in this loop. I'll first use the remainder operator to get the last digit and add that to sum. Then I'll divide number by 10 and start a new loop iteration. Because I don't know how many digits I'll get in the number passed, the easiest way to code this is to use a while loop. I'm going to keep processing number while it's greater than 9, in other words, while there is more than one digit to process. So I'll add this code starting on line 19. I'll type this in, then discuss it after I've got it coded. While number greater than 9, sum plus equals number modulo 10, number equals number divided by 10. Okay, so I have a while loop with a condition that says it's going to keep looping while number is greater than 9. So this will keep looping while the number still has more than one digit. On line 20, I'm getting the remainder value left from dividing by 10, which I've said was the last or rightmost digit. I get this number and simply add it to the existing sum variable all in one statement. I could have split this up into several statements, but here I'm showing it to you in one because I think it's a little easier to read. On line 21, I divide number by 10, and you'll remember why I'm doing this. Dividing an integer by 10 effectively drops the rightmost digit, and then that's it. This loop will keep looping while number is greater than 9. But I still need to add that last digit to sum, and I'll do that outside the loop after the loop closing brace on line 22. Again, I use the compound assignment operator, so that sum is equal to sum plus the remaining number, which I know is less than 10. Sum plus equals number. Before I run it, consider what happens if number is a single digit. Sum will start out at 0, then I'll get to the loop. But look, the loop will get skipped because number is not greater than 9. So the code falls through to the last lines, number gets added to sum, which is still 0, and then sum is returned. So in essence, this is almost as good as simply assigning number to sum, in this case, when the number is less than 10, which means the code is pretty efficient and uniform. I could have added code after the validation code to simply return a single digit number, and that would have been a valid solution too if you did that. So does this code work? Well, let's run it and see. And you can see that it's correctly summed the digits for 1, 2, 3, 4 and 3, 2, 1, 2, 3. It's returned -1 when the number was a negative number, and it returned the value 4 when I gave it 4. So that all looks good. So as you can see, the tricky part here was to extract and drop the least significant or rightmost digit in each loop iteration. This is a great example of using the remainder operator to extract digits and the division operator to truncate integers. I hope you got a lot out of this challenge and that you managed to complete it, and I'll see you now in the next video.